Hi everyone, welcome to a special episode of the Flag Tags, which we're making for the Science Rendezvous. So for anyone who's new here, the Flag Tags is a podcast that is ran by myself and 3 other undergraduates in the biochemistry department at Memorial University. Today we're going to be showing you a few little science-y things that you can watch or try right from home.
Hey everyone, so today we're going to be doing a at-home experiment that looks into the solubility principles of proteins. So today we're going to be using a little bit of milk and vinegar to look at casein curds, which is a type of protein that you find in a mammal's milk. And the vinegar and milk will actually form curds, which are like white substances that are actually the fat and the casein protein found in milk. So to start off, I'm going to measure half a cup of milk. Just give me a second. So milk is typically used by mammals to feed their young, so it makes sense that there is a lot of complex proteins found in your milk. And proteins are typically a string of amino acids, and in their primary structure, it's just like a string of beads. However, in order for them to be functional, they have to fold up. So I'm putting in 1 tablespoon of vinegar. So your protein has to first fold up in order for it to be able to interact with other molecules in its environment. However, if you put in heat or if you put in acid or base that changes the pH, it can cause the interactions within your protein to break, and then it is no longer folded. It will become a string of amino acids once again. So we're going to look at some denatured proteins in milk today. So I'm going to take this over to the stove now. So we've now put the heat on our milk and vinegar mixture. And proteins usually become denatured in acidic conditions. So in this case, we used vinegar, which will cause a acidic condition. And we're also adding heat, both of which will denature the casein proteins. And this will cause different regions of the protein that were usually buried inside the core to now become exposed. And these molecules will end up binding with other molecules of casein and form large insoluble precipitates, and that's called curd. So humans love curd, and they use it particularly in cheese. So the curd, which is the fat and the casein protein, becomes separated from the whey, and this is the liquidy, watery carbohydrate and some protein component. So I think it's just separating here now, and I'll show you really quick. So the proteins have denatured and have formed large aggregates. And now we're going to strain this and see what we got. Okay, so now that our curds and whey have separated, as you can see, there's little chunks of curd, which are the aggregated proteins, and we're going to strain it now through a strainer. So here we go. Just pouring it through. And you can see that the liquidy water component, or the whey, is now found in the bottom portion, while the proteins and curd aggregate is at the top. So once a protein becomes denatured, it's no longer soluble in the watery component.
For this experiment, we're going to be looking at the pH scale. So first, pH is a scale used to specify the acidity or basicity of an aqueous solution. It is a logarithmic scale that inversely indicates the concentration of hydrogen ions in a solution. The scale ranges from 1 to 14, with the smaller numbers being more acidic and the higher numbers being more basic. 7 is considered neutral. The acidity of a solution has a powerful influence on its properties. Acidic solutions are those that have more free hydrogen protons, and basic solutions have more hydroxide ions. pH is a highly regulated and essential property within the human body. A good example of this is our blood's pH, which sits at about 7.4. If it were to rise above 7.8 or fall below 6.9, we would die. Acidity is also tightly regulated in many of our essential biomolecules or nucleic acids, which can be highly affected by the concentration of the hydrogen ion, or the pH. Most proteins become denatured, or basically unfolded, when exposed to high concentrations of hydrogen ions. In our experiment, we will be looking to see the effect of adding an acidic solution, in this case lemons, to our aqueous solution, black tea, and see the effect it has on color change of the solution. So for this experiment on pH, we have a glass of hot water that we've steeped with a tea bag for about 2 minutes, and we also have some chopped lemon. So we're going to use the lemon to show what happens when we add an acidic solution to an aqueous solution. After letting our solution sit for a few minutes, we can see that the addition of the acidic lemons has lightened or increased the color of the black tea, indicating that the addition of the acidic lemon has decreased the pH of our tea.
So my experiment is going to be a little bit about acids and bases. So what you need to know is that acids contain a higher amount of protons, while bases contain a higher amount of the hydroxide ions. And we measure acids and bases using the pH scale, which runs from 1, which is more acidic, to 14, which is more basic. And you don't really need to know anything about this equation for how you calculate pH. Just know that a small change on the pH scale is a really big change in the amount of these ions that are in the solution. So when we're doing science in the lab, we usually want a way to know if our solutions are an acid or if they are a base. So we use things called indicators, which change color based on the acidity or basicity of the solution. So one indicator that you have at home maybe is red cabbage. So this contains flavin, which it's a molecule that changes color based on the acidity. So you can see here it'll turn more red when something is more acidic, and it'll turn more green when things are more basic. So to do this experiment, you're going to want to put some red cabbage leaves into a container or a bowl, and you're going to want to add some boiling water to that. Okay, now we're just going to let this sit for about 10 minutes. Okay, so now that your cabbage has been sitting in the boiling water for 10 minutes, you can see that it's like a nice purple-blue color, which indicates that our water is right here in the middle of the pH scale and it's neutral. So what we're going to do now is we're going to test out a few other things you might find around your house and see if they are acidic or basic. So let's just add some of our indicator into a different glass. You might want a few of these depending on how many things you want to test out. Okay, so you see that nice purple color. We're going to start by adding some vinegar, and we're going to see if the color changes. All right, so you see you're getting this nice pink-red color. So if you look back at our pH scale, remember we said that down here in the early numbers, it would turn red, and that means it's acidic. So vinegar is really acidic. All right, let's get some more and try something else. So acidity and basicity is really important in biochemistry because it can change the way proteins work, and your whole body is made of proteins. So next, we're going to try the baking soda. So let's just add a spoonful in and see. There we go. Add a little more. All right, so this one, you can see it turned like a really light blue. So that goes a little bit above 7 on our pH scale. So it's a little bit basic, it's baking soda. So remember from before when we talked about acids and bases, the vinegar contains more protons and the baking soda would contain more hydroxide ions. All right, we're gonna try one more thing. Let's add enough in so that we can see it. This is our last one, so we can use plenty. Right. And for this one, we're going to squeeze in a lemon. All right, so again, we're getting this nice pink-red color. So just like the vinegar, we know that a lemon is acidic. Thanks for watching.